A very good morning. I will be taking up the topic of reinforcement detailing of various RC structural member or the element as per the prevailing codal provision. So, in the first lecture, I will be taking up the reinforcement detailing of the columns in the RC structure. So, first of all, what do we understand by detailing of the reinforcement? We all know that the designers carry out the design of any structure as per the established theories and comes to various safety conclusions with the recommendation. So, we can say the detailing is the art of the designer to put his findings oblique the recommendations on paper, so that is followed by the ground executives like engineers, supervisor or finally the bar binder. They have to implement the technical requirements by means of detailing to the structure on site. So, now we can understand even if the designer designs using the most advanced software that are now available, which gives fairly or highly accurate results, if the same is not implemented on ground by means of the effective detailing, the structure will fail in its intended purpose. Hence, the detailing is very much necessary for all the structure like RCC cast in situ, precast structure, pre-stress or the post-tension structure, even in the masonry structure, and very much required in case of the cell or the dome structure. So, as we know that the column is the most important structural element in a frame structure, and we will be discussing the detailing aspect of the columns in this lecture. Now, coming to the various detailing checks and the aspect I am covering. Now, first is the mix up of the bars. In the left side of figure, we can see I have marked is a do not and the right side is the do. The do not case we can see the two grades of reinforcement have been provided. One is the TOR 40, that is FE 415, other is the TOR 50 FE 500. This kind of setup should not be allowed on the structural drawing, because it is very difficult for the bar binder to follow the specification on the ground. What he will do? He will get himself confused, even the engineers or the supervisors, they will also get confused and do the mistake. So, what invariably you have to do, that we have to follow a single grade of steel like either FE 415 or FE 500. That will also ease out any confusion on the side, and people will follow the right proposition of reinforcement. Now, second point what I want to show is the staggering of the bars in the continuity of the column. The left side figure is the do not, where you can see at one location here all the bars are getting now discontinued. Why it happens? Basically is the reinforcement are generally manufactured in a particular length, that is either 8 meter or 10 meter. If we start everything from the bottom, as the generally bar binder does, to avoid any wastage of the reinforcement, what will end up at one point all the bars would be ending up in the similar point. As the codal provision, we have to ensure that not more than 50% bars are lapped at any particular location. So, do that one, we have to tell the bar binder from the very beginning that he has to accordingly manage, so that at any point or any section only 50% bars can be lapped or overlapped. So, that purpose again what we can do, if we are not able to carry out because of mistake or initially he has forgotten to do that kind of thing, what we can best do as per the code, that we have to provide the stirrup at this overlapping location, and the stirrup spacing would be half of the usual spacing of the stirrup in that column. So, by this means we could be achieve the strength requirement of the joint in a column. Now, coming to the one more aspect, important aspect, that is the bar lapping at the column and beam junction. Column beam junction is the most important part of the point in any structure. So, here we can see in the left side of figure what is actually happening. We can see the bars are now getting, we can see where the beam is now getting junction into the column. We can see the bar lapping has been given inside the joint. This is not recommended at all. What this does, it will reduce the stiffness and the strength of the junction itself. So, we have to ensure the bar binding should be done accordingly, that the lap length should be out of the junction itself. We can here see in the right side, now the column bar has been given a lap length over the junction. This should be the actual practice you should be following. Another thing we can see in the left side, at the junction there is no tie provided at the junction. This should not be done. As far as possible, we should provide a tie preferably at the junction itself, as generally done usually in the column. This will enhance the rigidity of the junction. But at many times actually it happens, because the bar binder, due to the congestion of the rods or the bars at the junction, they generally do not carry out or not able to carry out this kind of setup. But as a technical requirement is there, we have to ensure the ties are provided at the junction itself. Now, coming to the abrupt kinking of the bars in the column. Left side figure, you can see there is a change in the dimension of the column in the bottom story and the top story. The top story column dimension is lesser than the bottom story, but at the same time we have to ensure the column bars are continued inside the top story to maintain the structural integrity. So, what the bar binders generally do is they take off this column bar from the bottom, and when it reaches the top column bottom, then they give a just kink, and again that they continue the bar inside. This practice is not recommended to be followed on the ground, because it is defeating the structural integrity purpose of providing the reinforcement. So, you can see on the right side under the do figure, what I can show you that how the column bars are taking a smooth transition into the next story column. You can see a transition is given, and the transition slope should be not more than 1:10, and you can see that offset should be not more than 15 degree, giving a transition. So, in this manner the column bar should be continued inside the top story column. Again the same thing on the left side, you can see the bar binder generally does not give the tie inside the junction. This should be also avoided in the ground. On the right side, you can see that one tie is preferably should be given at the junction, so that the rigidity of the junction is maintained. Again, coming to another aspect or another situation where we face this kind of situation as shown in the left side of figure. In this case, the column dimension of the top story is lesser than the dimension of the column in the bottom story. So, in this case, what the bar binder intends to do, they continue the column bar to the top, and from outside itself, not even inside, from the outside itself they bend the bar and continue inside the top story column. And that exposed portion later on what they do, they give some kind of concreting like a hunch portion on the outside, which has got no structural meaning at all. So, this setup should altogether be avoided, and we can follow what is shown on the right side, like the transition is again given at a slope of 1:10 or a offset of 15 degree, and the column bar is transitioned smoothly into the top story column. And again the same thing, the tie should be preferably placed in the junction itself to maintain the rigidity of the joint. Now, coming to the defective provision of the ties in the column, we will see how the tie should be actually given inside a column. Here we can see in the do not figure that again the stirrups were continuing from the bottom story and the top story, but at the junction itself where the beam is meeting the column, there is no stirrup. This setup generally actually the bar binders intend to do, because the beam stirrup would be coming from one side, beam reinforcement would be coming from one side. So, at this junction there is a heavy congestion of the reinforcement. So, they think it is not advisable to give this tie, because there is a heavy reinforcement here, and also it is very difficult to put the concrete over here during concreting, put the vibrator inside it. So, it is better to avoid the ties. But at the same time, if we go by the codal requirements, the ties are very much necessary at this junction. Ties provides the rigidity to the junction, which is a weak link during the performance of the structure in earthquake. So, we have to ensure the rigidity and integrity of the junction are maintained all the time and every time. That I have taken references from the various IS code like 456, SP 34 1987. If you want to know much more into the detailing aspect, you should be following the code SP 34, and various situation as for the various aspect, different detailing angle has been mentioned in this code. Though this code is quite old, but still it is followed in the true spirit of technical requirement, and other materials are also available. You can also go through that. So, with this I will conclude this first lecture on the column reinforcement. I thank you for viewing this lecture.